Okay guys, welcome back again. In today's video, I'm going to solve question 7 from November 2020. Okay, so this is the question 7. You can see you have 3 questions. You can see 7.1, and on 7.2 you have 2 sub questions. So in total you have 3 questions. Okay, you need to solve the 3 questions. Okay, in order to solve this question, you'll need to be able to determine the derivative using first principles, and you'll need to determine the derivative using the rules of differentiation. Okay, let me get started on the next slide. Okay, 7.1. Let me get the question again. This is the question 7 from November 2020. Okay. So this is the question. Let me put it here. You can see the question there. 7.1. Determine f prime of x from first principles if f of x is equal to 2x squared minus 1. Okay, this is f of x. The question is asking you to determine f prime, or the derivative of f of x. So you have to use the first principles. Okay, so f of x is equal to 2x squared minus 1. You are given that. Okay, before you can solve this question using the first principles, you can quickly check what your answer will be by using the rules of differentiation. Okay, the reason I personally do that is because the rules of differentiation used in grade 12 are quicker and simpler to use. Okay, you can do that quickly, but the question is not asking you to use the rules of differentiation. I'm just giving you this as a bonus tip so that you can check what your answer will be at the end. Okay, so the reason I'm using that is because the rules of differentiation are quicker and simpler. Okay, let's do that. Let me put a line here. So using the rules of differentiation, this is f of x. It's given there. You can see it's given 2x squared minus 1. Okay, the reason why I have my coefficient and my exponent in different colors is because I want you to follow this properly. Okay, I'm using the rules of differentiation, but the question is not asking me to use the rules of differentiation. The question is asking you to use what? The first principles. Okay, I'm using the rules of differentiation just to check what my answer will be in the end if I use the first principles. The rules of differentiation are quicker and simpler to use. Okay, this is just a bonus tip. You can use this in your exam. Just do it on a different piece of paper. Check what your answer will be in the end. But you have to follow what the question is asking you to do. The question is asking you to use the what? The first principles. Okay, for now, let's use the rules of differentiation to see what the answer will be in the end. Okay, so the derivative of f of x, which is f prime of x, is equal to, according to the rules of differentiation, what we have to do is to take that exponent, you multiply it by the coefficient. You can see, so I have my exponent in blue and my coefficient in green. Okay, the reason I got my exponent and my coefficient in different colors is for you to follow this properly. Okay, according to the rules of differentiation, if you wanna find the derivative of f of x or find f prime x, what you have to do is to take that exponent, you multiply it by the coefficient, can you see? And then x to the power of 2 minus 1. So you subtract 1 from the exponent, okay? Minus 1. And then you have negative 1. So this is the constant. Remember, when you are taking the derivative of a constant, this will give you 0. So the derivative of a constant is 0. So it will be minus 0 or plus 0, okay? So the derivative of a constant is 0. And so f prime x is equal to, you have 2 times 2, which is 4, and then x to the power of 2 minus 1, which is 1. So the final answer is 4x. Okay, it is minus 0, you can see. So the final answer is 4x. Okay, now you can see when taking f prime x using the rules of differentiation, the answer is 4x. But the question is asking you to use what? The first principles. Okay, now I know what the answer will be in the end. I must find what? 4x when using the first principles. If I don't find 4x, then there is something wrong in what I'm doing. Okay, so this is just a bonus tip. You can see it's quick, unlike the first principles, which is longer, and sometimes you can make mistakes throughout your workings. Okay, now let's use the first principles. You must expect what? To find your final answer to be 4x. Okay, so now f of x is equal to 2x squared minus 1. Okay, and using the first principles, f prime of x is equal to, this is what? The definition. This is the formula when you are taking what? F prime of x, or when you are taking the derivative of f of x. This is the formula to use. Okay, sometimes they can ask you determine f prime of x from the definition. If they say from the definition, they still want you to use what? The first principles. Okay, it's not different from the first principles. If they say use the definition or use the first principles, it's still the same thing. They want you to use this. Okay, now f prime of x is equal to limit as h approach 0. You have f of x plus h minus f of x over h. Okay, let's use this formula to find what? F prime x. Okay, now this is equal to the limit as h approaches 0. Now what we have to do is to take x plus h and plug it wherever you have x. You can see you have x squared there. You are going to replace that, or you are going to plug x plus h in there. Okay, so it will be 2 times x plus h, and remember square. Okay, so you can see I have replaced my x with x plus h. So wherever there is x, you replace with x plus h. Okay, and then you have minus 1 there. Okay, let me put this in square brackets like this. I like doing this. Okay, so we have everything there, and now minus. Now you have f of x. So now you are going to plug what? X wherever there is x. Okay, so you just have what? 2x squared minus 1, and you close your square bracket. You can see you start by plugging in x plus h in there. You have this, and then you plug in x in there. You have this. You can see. So you plug x there, you still have this. You plug x plus h, it gives you this. Okay, so this is over h. So this is what we are using the definition, or we are using the first principles. Okay, and so this is equal to the limit as h approaches 0. Okay, let me do this. Maybe I can close this. Okay, so you have the square bracket 2 times this. Remember, this is to the power of 2. So you have x plus h twice, like this. X plus h times x plus h. You can see x plus h twice, because it is to the power of 2. You can see that. And then minus 1. You close your square bracket. Then minus there, and then you have this. Okay, I hope you are following. It's over h. Okay, you can see I have x plus h times x plus h, because you have x plus h to the power of 2, so it's twice. Okay, you carry on. This is equal to the limit as h approaches 0. You have your square bracket. You have 2 times, when you solve this, you have x times x, which is x squared, and then you have x times h, which is xh, and then you have again h times x, which is xh. So you have xh plus xh, which will give you plus 2xh. You can see that. And then after that, you have h times h, which will give you plus h squared. Okay, you close the bracket, minus 1 there. You can see that. You can see the 2 is multiplied by this. Okay, you can see I have it there. and then you have minus 1 there. You close your square bracket, and then minus there, and then you have this part. Okay, let me do it slowly so that you can follow along. Okay, I don't want you to be confused. Okay, so this is over h, you can follow that, and this is equal to, when you carry on, you have the limit as h approaches 0. Okay, so you have 2 times x squared, it will give you 2x squared. You have 2 times 2xh, it will give you plus 4xh. And then you have 2 times h squared, it will give you plus 2h squared, right? Minus 1. Okay, you can see that the 2 is multiplied by everything there in the bracket. Okay, you can see. Okay, and then you carry on, you have minus in front of the square bracket there. So what we are going to do is to change the signs inside. You have a positive in front of 2, so it will be negative 2x squared, you can see, and then this will become plus 1, you can see, because there is negative 1 in front of the square bracket. I hope you can see that. Okay, this is over h. Okay, and so you can see you have 2x squared minus 2x squared, this will go, and then you have negative 1 or minus 1 plus 1. You can see that this gives you 0 again. Okay, so you only have this and this remaining. So when you carry on, it will be the limit as h approaches 0. You have 4xh plus 2h squared. So this is what you are remaining with, over h. I hope you can see that. Okay, and this is equal to, can you see, you can carry on by factorizing h. You can see what is common in both there. You have h there and you have h there. So when you carry on, it will be the limit as h approaches 0, and then you factorize h because h is common in both. So you take h out of the bracket like that, and then here you remain with 4x plus 2h, right? Because you have 2h squared. So you can see when you multiply throughout, h times this will give you 4xh, h times this 2h, it will give you 2h squared. Okay, so you factorize h outside of the bracket, and then you have in the bracket 4x plus 2h. You close your bracket, over h. Remember, it's over h. Okay, now you can see this h and this h will cancel, right? It will cancel. Okay, so you carry on. This is equal to the limit as h approaches 0. So you only have this 4x plus 2h. Okay, so now from here what you have to do is to substitute 0 for h. You can see, so when you substitute 0 for h, you have this is equal to, you have to drop now this part. This part, can you see this part? Limit as h approaches 0. When you substitute 0 for h, this is the only time you can drop this part. Okay, so you have 4x plus 2 times h. You substitute 0 for h, so it's 2 times 0, like that. You can see I don't have limit as h approaches 0. I don't have it here. Why? Because I have substituted 0 for h. You can see there is h. I have substituted 0 for h. You can see this is the only time you can drop this part. When you substitute 0 for h, you don't have this part there because you substitute 0 for h. This is the only time you can drop this part. Remember that. Okay, and this will give you, you have 4x plus 0. This is 0, and the answer is 4x, right? This is the final answer. You can see 4x there when we used the rules of differentiation, and we found 4x when we use the first principles. Okay, so what we did here is correct. If we found something else than 4x, then you have to check what you've been doing in there. There is probably something wrong that you did. You can see the final answer is 4x, just as we found it using the rules of differentiation. Okay, now let's move on to the next question, 7.2. Now 7.2, let me get the question again. So it's question 7 from November 2020. Okay, this is the question. We are now doing 7.2. So you have 7.2, determine. You have 7.2.1, determine d of this, what we have in the bracket, with respect to x. So what they want you to do is to find the derivative. Okay, do not be confused with the notation. They want you to find the derivative. I hope you can see that in the video I'm going to post on calculus. Okay, I'll post a video on calculus where I'm going to explain all this. For now, you have to know that they want you to find the derivative of what is in the bracket. Okay, let me write down the question. So 7.2.1, we have this. Okay, they want you to find the derivative of what is in the bracket. Okay, this is equal to, before you can find the derivative of what is in the bracket, you can see you have the root symbol. You have to get rid of that, so that it can be easy for you to find the derivative. Okay, so this is equal to this. In bracket you have, remember this is x to the power of 2 over 5. So you have a fraction 2 over 5. Okay, like that. The 5 is obtained there. You can see you have the fifth root. This is the fifth root. Okay, so I can change this into x to the power of 2 over 5. Now I have that fraction. Okay, and then plus x cubed. You can see, you close your bracket. Okay, now from here, this is simple to find the derivative. I got rid of what? The root symbol. Okay, now let's carry on. This is equal to, you have two parts. You have this part plus this part. This is equal to, you take the derivative of the first part, this part, plus the derivative of the second part. So this is according to the rules of differentiation. Okay, the second part is x cubed. You can see this is the first part and this is the second part. So when we have two parts added like this, when you have addition or subtraction, you can take the derivative of the first part plus or minus the derivative of the second part. It can be 3 parts or 4 parts or 5 parts, as long as you have them in the bracket like this and you have this derivative sign in front of the bracket. You have to take the derivative of every part inside the bracket if you have addition or subtraction. This is according to the rules of differentiation. Okay, I can close this so that we can have enough space to solve this. Okay, now when you carry on, remember, according to the rules of differentiation, what we have to do is to take the exponent. The exponent is 2 over 5. You multiply it by the coefficient. The coefficient is 1. There is an invisible 1 in front of x. So the coefficient is 1 and your exponent is 2 over 5. So 2 over 5 times 1 will give you 2 over 5. And then x to the power of that exponent, you subtract 1 from that exponent. So it will be to the power of 2 over 5 minus 1. You can see the exponent, you subtract 1. This is according to the rules of differentiation. Okay, plus now the second part, you do the same. You have the exponent, which is 3, and the coefficient is 1. There is an invisible 1 in front of x there. So it will be the exponent times the coefficient, that is 3 times 1. It will be 3, and then x to the power of, you subtract 1 from the exponent. So it will be 3 minus 1, like that. Okay, so this is according to the rules of differentiation. Okay, and you carry on. This is equal to 2 over 5 x to the power of, when you do this, 2 over 5 minus 1, this will give you negative 3 over 5. Okay, if you are not good with fraction, you can use your calculator to check that. So it's negative 3 over 5. Okay, plus 3x squared. This is 2. 3 minus 1, it's 2. So it's 3x squared. Okay, and this is the final answer. Okay, we have solved the question. Okay, now the next question, 7.2.2. Let me get the question again. What is the question saying? The question says determine 7.2.2, determine f prime x if f of x is equal to this and x is not equal to negative 3 over 2. Okay, we are given f of x is equal to 4x squared minus 9 over 4x plus 6. You are given it. Now the question is to determine f prime x, or the derivative of f of x, right? Okay, let me close this. You can see right now, as it is not easy to determine f prime x, or the derivative of f of x. What we have to do is to first do some factorization and do some simplification, and from there you can now determine f prime x, or the derivative of f of x. Okay, let's do that. So f of x is equal to, can you see you have two squares here? Can you see this is 3 to the power of 2 will give you 9, and this is 2x to the power of 2. Can you see 2x to the power of 2? So you have difference of two squares. So you can factorize this into two brackets like this. Okay, and this 4x squared, it will be 2x and 2x. Can you see when you multiply, it will give you 4x squared. And this 9, it's 3 and 3. Okay, so you have two squares there. This is difference of two squares. You can factorize it like this. And now you can have negative there and positive there. Or you can put positive there and negative there. It doesn't matter how you do it. Okay, so we have factorized this difference of two squares. Okay, now this is over. What can you do here? You can see you can factor out 2. There is 2 in both. You can factorize 2 outside of the bracket. So it's 2. You open your bracket. Now you have what we have inside there. You have 2x. Can you see when you multiply this 2 times 2x, it will give you 4x. Okay, plus what we have, 2 times what, 3, it will give you 6. So you factorize, you take 2 out of the bracket, and inside the bracket you remain with 2x plus 3. Now you can see you can do some cancellation. You can simplify this. You have 2x plus 3 there, and you also have 2x plus 3. So this and this can go. And so f of x is equal to, there is an invisible 1 there in front of this bracket. So you have 1 over 2 like this. Okay, times this bracket, what you remain with. Can you see? Okay, and now from here you can see this is simple. You can now take what, the first derivative when this is simple. Unlike before, this was not simple to take the first derivative. From here it is simple. You can now take f prime x, or the first derivative. Okay, so this is equal to, you have this coefficient or this constant which is multiplied by this bracket. So there is multiplication there. So you can take out 1 over 2, and then you take the derivative of what we have in the bracket there, because the constant is being multiplied by what is in the bracket there. You can take out 1 over 2, this constant, and then you take the derivative of what is inside the bracket. So when you take the derivative, it will be 2 minus 0, or 2 plus 0. Can you see that? According to the rules of differentiation, you have x to the power of 1. There is a power of 1 there. So you take 1 times 2, it's 2 times x to the power of what? 1 minus 1. Remember, there is 1 there. You subtract 1 again, you end up with x to the power of 0. So x to the power of 0 is 1 times the 2, it will give you 2. And when you take the derivative of this constant, this will give you 0. So you just have 2 minus 0 or 2 plus 0. So it will be 2 only, okay? And so f prime x is equal to, when you multiply this, it will give you 1, okay? So this is the final answer. And we are done with question 7 from November 2020. So if you find value in the video, please don't forget to like, comment, and subscribe to the channel. Don't forget to activate the notification bell so that when I post new content, you can be notified, okay? If you'd like me to make other videos on other topics, let me know in the comment section. Until next time, I'll talk to you soon.